Hi, everybody. Welcome to Lecture 101. Today, I'm going to talk about antibiotic resistance, one of the great challenges in biomedicine. So, I'm going to use the example of drug-induced HIV resistance, and hopefully, by the end of the day today, you guys will be able to apply the same concept to antibiotic-resistant bacteria. We all know about HIV. It caused AIDS epidemic in 1980s, and a lot of people died from AIDS. But not until 1995, then only the HIV doctors initiated the so-called combination antiretroviral therapy, which is what they known as the HART therapy. This involved a combination of drugs to improve patient prognosis and also at the same time reduce HIV resistance. But just because the patient has to be put on life to take this pill daily, they will surely experience a lifelong severe reaction. So in order to reduce the reaction, the doctor would like to know if interrupted treatment is as good as continuous treatment. Therefore, they started this study called the SMART study. Not until the year of 2006, this study stopped completely, reason being a lot of HIV patients progressed to AIDS. A lot of HIV patients die from AIDS, and a lot of patients experience severe complications. That is really bad. But what can we learn from this SMART study? Well, the take-home message from this SMART study is that we must follow a stringent adherence protocol. Why? Let's say today we have HIV patient, he forgot his pill for a week. This can reduce the bioavailability of the drug in the blood, and some of the HIV can replicate, and also at the same time accumulate additional mutation. So even then you take your HIV pill afterward, this can suppress some of the wild-type HIV strain. This is what I known as the unmutated type. But at the same time, because of the accumulated mutation, the mutated HIV will be re-emerged from the dominant repertoire and therefore lead to drug resistance. Well, can we really apply the same concept to antibiotic-resistant bacteria? Let's have a look. Since the first discovery of penicillin in 1940s, there were a lot of cases of antibiotic-resistant bacteria being reported. For example, MRSA, multi-drug-resistant TB, and also the most recent one, superbug gonorrhea. Then you would ask, why is antibiotic resistance happening? Is it necessary though? Well, let's imagine this. What if the whole bacterial population being wiped out? Then we would have no good bacteria for our bowel movement. That means we cannot poop. Just kidding. And also we will not have waste decomposition and etc. So we have to bear in mind that bacterial mutation is part of the natural occurring process for their survival. But there are two factors that can actually accelerate bacterial mutation. First, poor adherence to dosing regimen, and also the abuse of antibiotics. So, what would really happen if the bacteria mutated? Well, they will become resistant to antibiotics. So, in order to do this, the bacteria must acquire a gene called antibiotic-resistant gene. Through these genes, they will be able to resist antibiotics through four basic mechanisms. The first one, the bacteria will be able to modify the cell wall. That means antibiotic will not be able to go into the bacterial cell. Second, they will be able to modify the drug targets. That means antibiotics can still go into the bacterial cells, but will not be able to target on the bacterial cell. Third, they will be able to produce drug inactivating enzyme that is used to degrade the antibiotic. That means they will be no longer functional. Fourth, which is what I think the most clever one. You know why? Because they can produce efflux pump that pump out the antibiotic that is already inside the bacterial cell to the outside. So now we have the antibiotic-resistant bacteria. What are the challenges in biomedicine? Well, the first thing that I can really foresee is treatment failure, because infections become harder to treat, and this will add on opportunistic infections which increase mortality and also morbidity. In order to kill all these bacteria in one shot, we need to increase the use of antibiotic. This will directly increase the adverse side effects, which involve kidney failure and also liver failure. Because of the hospitalization, admission, and increased use of antibiotic, this will impose a huge economic burden on healthcare. But is that all? Is that all the challenges that I want you guys to think about? No. Because I have the last one and the tough one for you guys to think about. Let's imagine this. Will the entire living population be wiped out if the drug-resistant microbe dominate us? Will we die? Will we? Come on, let's think about this. It's getting very interesting. So, now we run out of antibiotic. The bacteria become more infectious. Once they infect us, we die. No? Well, while you're thinking about your answer, I already have mine. You might be disagreeing with me, but let's listen to this. My answer is no, we will not die. Because if the bacteria evolve, so do humans evolve too. Because we are smarter. Come on. So in the future, these drug-resistant microbes can become a normal flora. That means they will not be a threat for us. Then we can coexist in the same ecosystem. So I hope you enjoy my lecture today. But before you go, right before you go, okay, I am very angry. You know why? Because you guys are rude. You guys haven't asked me who am I and why am I giving you this lecture. Well, to begin with, I am Dr. Jason Liu. I graduated with a PhD degree in physiology with exceptional thesis in the Division of Biomedical Sciences, University of Otago from New Zealand. I was also trained as a junior scientist at the Radcliffe Department of Medicine, University of Oxford. And I really enjoy talking about this with you guys, and I really hope to see you guys next time. Peace out.